presenting lab 1 with the charge tape. So this lab observes and measures charge interactions in everyday objects using the fact that like charges repel one another while opposite charges attract one another. Using the results from this lab and Coulomb's law, my code will be written to determine the amount of excess charge on tape. Also using the derivation of Coulomb's law, you can predict the outcome prior to the experiment, because if you know that if Q1 and Q2 have the same charge, the formula below will show that Q1 and Q2 will be positive, which denotes repulsion, whereas if they were opposite charges, they would be negative, which will denote attraction. The lab also utilizes Newton's second and third law, which you will see later on in the code when I do the free body diagram. And you know the acceleration of an object that's produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object. And you also know that every action there's an equal and opposite reaction. And they're useful in predicting the forces acting on the floating tape, like I said, as you can see in the free body section. So here's my data that I got from the lab. I found the U-tape length as close to 20 centimeters as I could, and I used the assumption that the mass is 1 gram per meter, and I used that to get an estimation for the mass. I noticed that the U-tape did attract to my hand, and as my expectations were proven, I expected that the two U-tapes would repel each other because they have identical charges, and I expected that they would attract neutral objects. Again, I also used the assumption that the tape is treated as a point charge, with all charges concentrated on the center of the tape, and each U-tape has the same amount of charge, just evenly distributed along the length of the tape. Here's pictures of my experiment. The first picture shows the first charged U-tape being attracted to my hand. It was also attracted to a negatively charged pin, which I can conclude that the U-tape would be positively charged, and both the U-tapes repelled each other. I didn't get a picture of them laying horizontal, but it was easier for me to get a picture of the two U-tapes as I held them up. So the question from the lab: if a U-tape is positively charged, how should it interact with the charged plastic pin? I said there'd be an attraction because if the pin is negatively charged and they did attract to each other, my U-tape would be positively charged. And if it was negatively charged, how would they interact? There would be repulsion because like signs have a repulsive characteristic. And how should a neutral U-tape interact with the charged pin? There would be an attraction because neutral objects have an attractive interaction with any charged object, positive or negative. And the other question: since the momentum of tape B is not changing, what can you conclude about the net Y component? I said the net Y component is at equilibrium. Again, going back to Newton's law, for every interaction there's an opposite and equal reaction. And if so, the momentum isn't changing, then they must be equal. And what objects in the surroundings exert mainly vertical forces on the floating tape? Tape A has the electrostatic forces from the repulsion, and there's also gravitational forces. My free body diagram will be drawn using the code, and I'll show that within the next slide. And in order to determine the gravitational force on tape B, what quantity do you need to measure? And that's mass, because the force of gravity is ma. Here is the coding section. So first I start with all my constants and the mass used from the assumption that mass is 1 gram per meter from my tape length, and then I found the distance between the two U-tapes. Next, I used the gravitational force, which is mass times the acceleration of gravity, and the electrostatic force is just the absolute value of that. To do Q charged, I rearranged Coulomb's law to solve for Q. So I took the square root of the electrostatic force times the distance of the tape squared divided by the constant. And for the number of electrons, I did Q charge divided by Q electron, the constant. And then for the tape B, that is on top of the tape A, for the charged U tapes, I just created a sphere with the radius big enough to see, using the mass and Q charge, gave it a color, and I did the same thing for the bottom tape. But I just set the distance apart, the distance I measured in the lab, and then I put the bottom tape at the origin. And then for the gravity arrow, it's just at the position of the top tape and pointing downward. And then the electrostatic arrow is at the upward position because they're equal and opposite. And then to find the number of atoms, I did tape length divided by the atom constant to find the atoms on the sticky surface. And then to do the ratio, I just did the electron number over the number of atoms. And here are my results. Again, this is an equal and opposite reaction on tape A, and here's tape B at the origin. Thank you.